Today, let's start solving the paper 2023 May June paper 42. 2023 May June paper 42. Let's start. First question. A particle of mass 1.6 kg is dropped from a height of 9 meters above a horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meter per second. Find the work done against resistance. So let's read this question again and make a diagram to understand it better. A particle of mass 1.6 kg is dropped from a height. So that means this is the particle with mass 1.6 kg and it is dropped from a height of 9 meter, which is this, above the horizontal ground. This is the horizontal ground. The speed of the particle at the instant before hitting the ground is 12 meter per second. So when the particle comes down like this, it touches the ground, the particle. The velocity of the particle at which it will hit the ground is 12 meter per second. Find the work done against resistance. So this is a classical question of work energy transformation or also energy transformation. And what is happening here that we'll see in a moment. Yeah. So the ball initially has which type of energy? Can you guys guess? The ball is not moving, so it does not have kinetic energy. So the other type of energy is it is on a height. So the ball has gravitational potential energy. And then the ball is going down and its speed increasing. So gravitational energy is being also converted to kinetic energy. But then they have also told us that it is doing work against resistance. So what is this resistance exactly? So here let's assume these small particles are air particles. So as the ball moves down, the air particles try to resist its movement. So the energy wasted in order to push the air particles is the work done against air resistance. So now we can form an equation that gravitational potential energy which the ball has, that is as it is stopped here, as it is being dropped, means someone might have held the ball, right? Because somebody has to hold the ball as it has to be dropped. So the ball is still, it has no kinetic energy, it has only gravitational potential energy. The gravitational potential energy is being converted to kinetic energy. Matlab, as the ball falls down, the gravitational potential energy turns to kinetic energy. Why? Because as the ball, once it reaches here, what will be its height? Its height will be zero. And because gravitational potential energy is mgh, as the height becomes zero, the entire GP will also become zero because anything into zero is zero. So if mg0, this will become zero. So that means gravitational, and it will have some kinetic energy because it is moving and it has velocity and mass also. It is being converted to kinetic energy, and also it is being converted into work done against air resistance, which I'll write as W bracket R. So we can, as we know the equation, as we know, energy cannot be created nor destroyed. So all of the gravitational potential energy that is created, it will all have to convert to kinetic energy and work done against resistance. So both will be equal. So now let's input the formulas for all the symbols here. So gravitational potential energy is mgh, kinetic energy is half mv square, and work done against resistance is the same thing because we have to find that work done against resistance. So next, the mass of the particle is 1.6. Gravity we consider 10 in mechanics. Height is 9 meter. Here in the question it is there, and we have been labeled it 9 meter. And the mass is 1.6. We know that. The velocity will be 12 meters square because they have told us the velocity at the instant it is hitting the particle is 12, which is work done against air resistance. So if we simply resubstitute it, it will become, if we put one, if we keep if we put it here, it will become 1.610 into 9, which is this, minus half 1.612 square is equal to work done against air resistance. Now we can put this in the calculator. 1.6 into 10 into 9 minus 1.6 upon 2 into 12 square. So the answer is 144 upon 5, which is 28.8. Now 28.8 what? 28.8 bananas? No, 28.8 joules. Because why? Because energy, the unit of energy is joules. So here you have the first answer. Now let's go to the second question. Let us start with the second question. Two particles mm, of masses 3.2 kg and 2.4 kg respectively lie on a smooth horizontal table. So that means if this is a smooth horizontal table, there are two masses, the first mass being A and the second mass being B. And these mass is 3.2 kg and 2.4 kg. Lie on a smooth horizontal table. A moves towards B with a speed of V meter per second. So this is V meter per second. And collides with B, which is moving towards A with a speed of 6 meter per second. So B is moving towards A with a speed of 6 meter per second. Okay. In the collision, two particles come to rest. Find the value of V. That means this is before collision. Let me write that as BC. And after collision, that means when the two particles AB, A and B collide, the speed is 0. That means both come to rest. So now what they have told us is to find the value of V. Now what is V? V is the value of the speed of A initially moving. So right, we can use initial momentum is equal to final momentum. Final momentum. Yes. So initial momentum is, the formula for momentum is mass into velocity. So the mass is 3.2 into V plus 2.4 into minus 6. Now why the minus 6? Because V is moving in this direction and the 6 is moving in this direction. So both are opposite. So we'll add a minus is equal to final mass, final momentum 3.2 into 0 plus 2.4 into 0. So right now it will become 3.2 V is equal to 2.4 plus 6, because this entire thing is a minus. If it goes to that side, it becomes a plus. So now entering the final step, V is equal to 2.4 into 6 upon 3.2. And now putting this in the calculator, 2.4 into 6 divided by 3.2. So the answer is 4.5. So the velocity is 4.5 meter per second. Okay, so the next question is find the loss of kinetic energy of the system due to the collision. So the loss of kinetic energy can be calculated as the total, uh, 1 second, yeah, the total loss of kinetic energy is equal to the initial kinetic energy minus the final kinetic energy of the system. Now the initial kinetic energy and final kinetic energy will also have two parts, and that will be first one, initial kinetic energy of A plus initial kinetic energy of B. Similarly, final kinetic energy will also have two parts. First one, final kinetic energy of A, and the second one, final kinetic energy of B. So let's first find the initial kinetic. So before that, let's know what the formula for kinetic energy is. So kinetic energy simply equals half mv square. So what is the initial kinetic energy of A? That will be half into what is the mass of A. The mass of A is 3.2, half into 3.2 into what is the velocity of A initially. Initially, the velocity was V, which we found out here. Find the value of V, which is 4.5. So half into 3.2 into 4.5 square. What is the initial kinetic value, kinetic energy of B? That will be half into mass of B. The mass of B is 2.4 kg and it was moving at 6 meter per second. So half into 2.4 into 6 the whole square. So let's find the value for both of these. So the value for half into 2.4 into 6 square is 43.2. And the value for half into 3.2 into 4.5 square is 32.4. Both of them being joules. So we found out the initial kinetic energy. What about the final kinetic energy? Now look very precisely at what they have mentioned here. What they have mentioned is that in the collision, the two particles come to rest. That means after they collide. This is before collision, that means initial. And this is after collision, which means final. So after collision, both have come to rest. And what did we discuss about the final formula for kinetic energy? Kinetic energy is half mv square. So if it is at rest, that means when v is 0, then kinetic energy will also equal 0. That means final kinetic energy of A will be 0 and B will also be 0. That means the entire final kinetic energy being 0. Therefore, total loss is equal to 32.4 plus 43.2 minus 0. And the answer for this is 75.6 joules. So we are done with this question. Okay, we'll start with the third question. Coplanar forces of magnitude 30 Newton, 15 Newton, 33 Newton, and 3 Newton act at a point in the direction shown in the diagram, where tan alpha is 4 by 3 and the system is in equilibrium. Show that this square plus this square is 1. And so the first step, what we have to do is we have to resolve these forces. What do I mean by resolve these forces? So look at this 30 Newton force acting at an angle alpha. So what we can do is we can take it at another side. So let me draw this here. This is 30 Newton and this is acting at alpha. Sorry, theta. My bad. Acting at angle theta. So now it will have two components, which is the horizontal component, which is the sleeping line, and the vertical component, which is the standing line. So what will be this standing line? That will be according to trigonometry, sine theta. Let this be the vertical line, that this is the horizontal component. So vertical component will be sine theta, which is v upon 30, and cos theta will be h upon 30. So v will be equal to 30 sine theta and h will equal 30. Well, let me write that again. H will equal 30 cos theta. So now we know that I can write this entire thing as 30 sine theta and 30 cos theta. And in short, this means, let me assume I have a carom board here. And this is where I place my striker here. This is my striker. Now, if I use my fingers to push it at this angle, so at a force of 30 Newton at an angle, let us consider the angle to be theta. Instead of doing this, if I have another carom board and if on the striker I apply a force of 30 sine theta here and 30 cos theta here, then it will have the same effect because I just resolved the forces into two different components, but the end result will be the same. It will move here only. So this is what resolving means. So we got 2 for 30 Newton. Now we'll do this the same thing with all the four forces and we'll write it down separately. So the first one is 30 sine theta and 30 cos theta. Now next, the 15 Newton force with alpha. So this line will become 15 cos alpha. Same logic, this trigonometry, this alpha. This is the 90-degree here. This is 15. So sine alpha will become V upon 15. And this is V. So this V, let me draw that again. 1 second. So this V will become 15 sine alpha. So now we have the second resolved vector to 15 sine alpha and 15 cos alpha. Now next is the 33 Newton. So there will be two forces too. One is this and the other one is this. So this will be 33 cos alpha. Why? Because let us assume this right here. This is angle alpha, 90-degree. This is on the same adjacent side. So the adjacent means cos. So cos alpha will equal horizontal upon this is 33 Newton. So 30-degree. This is horizontal. This is opposite. And this is hypotenuse. So this is 33 cos alpha. Similarly, this will be 33 sine alpha. So let me write that down here. This is 33 cos alpha. This is 33 sine alpha. And the last one remaining is P Newton. So now let us do that. Which color? Yes, this purple. So this will resolve into these two forces. So this will, because this is the adjacent side, this will become P cos theta and this will become P sin theta. So this is P sin theta. This is P cos theta. Now let's equate all of them. So right now, here they have told us that the system is in equilibrium. That means the resultant force is zero. That means all of these forces they combine to give a resultant force of zero. So can you look at these upward forces? See, so these two upward forces, these two upward forces will equal these two downward forces. Now, what do I mean by that? What I mean is 30 sine theta plus 15 sine alpha will equal 33 sine alpha plus P sine theta. Because this is the upward force up and this is the downward force. So because upward force equals downward force, and why? Because the system is in equilibrium. Similarly, now what we have done with up and down, we have to do it with left and right. Why? Because as the system is equilibrium and up and down forces equate, even the left and right forces are equate. So this one, 30 cos theta and P cos theta, they are on the left. And 15 cos alpha and 33 cos alpha are on the right. So we'll equate this now, 30 cos theta plus P cos theta is equal to 15 cos alpha plus 33 cos alpha. Alpha plus 33 cos alpha. Let me rewrite the alpha in a better way here. Yeah. So now we have both the equations. What we have to do is show that 14 point this is equal to 1. And now we have two hints here that tan alpha is 4 by 3 and we have sine alpha and we have cos alpha. So we can use that somehow to turn it into tan alpha, which will be 4 by 3. Now, how will we do that? First, we'll have to simplify both of these equations. So let me write down this down as equation 1 and let me write this down as equation 2. So now I'm working with equation 1. So what I can do is put this p sine theta right here and 15 sine alpha right here. So as I do that, it will become 30 sine theta minus p sine theta is equal to 33 sine alpha minus 15 sine alpha. So now as I simplify and as I factorize sine theta, as I take out sine theta in common, I'll get this equals 33 minus 15 is 18 sine alpha. And now next is the second one. Next I can take third cos theta simply as common and put 30 plus p is equal to, and taking cos alpha 15 plus 33 will be 48 cos alpha. So now we have the simplified versions of both the equations. This is the simplified equation 1. This is the simplified equation 2. So now what should we do? Now that we know that tan alpha is 4 by 3, now I'd like to mention here that tan alpha can be written as sine alpha upon cos alpha, and this is equal to 4 by 3. Now, as we know, tan alpha is 4 by 3, we can find out the value of alpha. How? We can simply put alpha is tan inverse of 4 by 3. And if we put this in the calculator, mm, yes, tan inverse of 4 by 3, the answer we'll get is 53.13 degree. And now what do we do about this? So what we have to find out is this square plus this square is equal to 1. Now we all know sine square theta plus cos square theta is equal to 1. So can we find out the individual, can we make sine theta and cos theta the subject here? Yes, of course we can. So we'll write it down right here. Yes. So sine theta will be 18 sine alpha upon 30 minus p. Similarly, cos theta will be 48 cos alpha upon 30 plus p. So now if we do sine square theta plus cos square theta equals 1, we already know this. So if you want to do sine square theta, then we'll have to square this entire thing. And if you want cos square theta, we'll square this entire thing. So what we got finally is 18 sine alpha upon 30. 1 second. This looks like I've cut it, but I have not. 18 sine alpha upon 30 minus p the whole square plus 48 cos alpha upon 30 plus p the whole square is equal to 1. Now we have already found out the value of alpha, which is tan inverse of 4 by 3. So let us substitute the value of alpha everywhere. And how would we do that? We'll do it like this. 18 sine tan in 1 second, tan inverse of 4 by 3 upon 30 minus p the whole square plus 48 cos tan inverse of 4 by 3 upon 30 plus p the whole square. And now let us simplify this in our calculator. So this will be 18 sine, let me 18 sine tan inverse of 4 by 3 and 2 brackets upon 30 minus p. So we don't need the 30 minus p right now, we just need this. The value for this will be 72 by 5, which is 14.4. So we can write 14.4 upon 30 minus p the whole square, plus now instead of instead of 18 sine, we'll write cos 48 cos tan inverse of 4 by 3. And the answer is, one second, what did I do? The answer is 28.8. So 28.8 upon 30 plus p the whole square. This is equal to 1, hence even this is equal to 1, and hence we have proved that 14.4 upon 30 minus p the whole square is equal to 28.8 upon p plus 30. Yes, 28.8 upon 30 plus p the whole square is equal to 1. And so we are done with this question. Let's start with question B. Verify that p equals 6 satisfies this equation and find the value of theta. So now that p, what we have given is that p equals 6. So now that we know that instead of p here, the p which was written here, the p is being converted into 6. So now, can you see that instead of this p equals 6, nothing has changed in this diagram? So 30 sine theta, 30 cos theta, 15 sine alpha, 15 cos alpha, 33 sine alpha, 33 cos alpha remains the same. Now, instead of p sine theta and p cos theta, we'll cut out the p and we'll write 6. So it will be that this 30 sine theta, these equations will remain the same too. But only difference will be that this p, this will be cut out and 6 would we'll replace it with a 6 here on both sides. Yes. So now let me copy the equation down. These two equations I'll just copy it down instantly. So now I have written down the both of these equations. Copied it down there, and instead of p I have written 6. Why? Because p is equal to 6. And now what they have told us is that find the value of theta. Now how do we do that? So the first thing we need to do is simplify equation 1 and 2. And to simplify equation 1, this sine alpha and sine alpha should be together, and sine theta should be together. So I'll bring the sine theta there and bring this sine alpha here. Hence, it will become 30 sine theta minus 6 sine theta is equal to 33 sine alpha minus 15 sine alpha. And so 30 minus 6 is 24 sine theta, and 33 minus 15 is 18 sine alpha. So we have this now, 24 sine theta is equal to 18 sine alpha. And we can even simplify this, but we don't need to simplify it to that extent. We can do it later. And next, we'll simplify the second equation. So 30 cos theta plus 6 cos theta is 36 cos theta is equal to 48 cos alpha. And now, remember, we were given the value of tan alpha as 4 by 3. So what we can do is we can input alpha, we can keep alpha here only, and we can write it as tan inverse of 4 by 3. So right here we have the value of alpha. Alpha is tan inverse of 4 by 3. And now what they have told us is to find the value of theta. So in order to find theta, first realize we have two values here. We have value, this is the first one. This one, 24 sine theta upon 18 sine alpha, and 36 cos theta equals 46 cos alpha. So what we can do here is we can somehow manipulate the equation such that it comes to sine alpha upon cos alpha. And how, why? Because then it will become tan alpha, and we know the value of tan alpha is 4/3. So how can we do that? First, let make sine alpha and cos alpha the subject. So if in order to make sine alpha the subject, what we'll have to do is, wait, let me write it with a different pen. Yeah, sine alpha will become 24 sine theta upon 18, and cos alpha will become 36 cos theta upon 48. And so sine alpha upon cos alpha will become 24 sine theta upon 18 divided by 36 cos theta upon 48. And so therefore 24 sine theta upon 18 into 48 upon 36 cos theta. What I did, I just reciprocated it. So now simplifying this in on a calculator, so I'll get 24 into 48 upon 18 into 36. So answer is 16/9. Therefore, sine alpha upon cos alpha is equal to 16/9. Sine theta by cos theta. And going down, sine alpha upon cos alpha will be tan alpha. Therefore, tan alpha is equal to 16 sine theta upon 9 cos theta. Now, sine theta by cos theta will also become tan theta. So we can erase this entire thing and we can write tan theta. Now we know tan alpha is 4/3. So what I can write here is 4 upon 3 into 9 upon 16 is equal to tan theta. How? This 9 went up, this 16 went down. Therefore, theta equals tan inverse of, let's simplify this in a calculator, 4 into 9 upon 3 into 16. So the answer is 3/4. So tan inverse of 3/4. So the value for theta will be tan inverse of 3/4, which is shift tan inverse of 3/4, 36.9. So the answer is 36. The actually theta was 36.86, rounding it off to 36.9 degree. So here is our answer. Let's move to the fourth question. An athlete, yes, an athlete of mass 84 kg is running along a straight road. So that means an athlete, let me draw the athlete right here. He's on a straight road. His mass is 84 kg and he's running. 84, yes. Let me rewrite it again. 84 kg. 84. Yes. Initially, the road is horizontal and he runs with a constant speed of 3 meter per second. That means he's running at a speed of 3 meter per second and producing a power of 60 watt. Now, this is a very easy question. Find the resistive force which acts on the athlete. So the basic formula for this is power is equal to force into velocity. So power is 60, force is we don't know, and velocity is 3. So therefore force will be 60 by 3, which is 20 Newton. That means the force exerted by the athlete to overcome the resistance force and still run a constant speed of 3 meter per second is 20 Newton. That means a 20 Newton resistive force is acting on the athlete. Next question. Oh, this is a big essay. So there is no reason to read it just like that. We'll read each statement and we'll understand what that means. And what do I mean by this? I'll tell you. The athlete runs up a 150-meter section of a road which is inclined at an angle 0.8 degree. Okay. So we'll have to start drawing the equation. Sorry, diagram. So let me draw slope right here. It should be a big slope as we have to mention a lot of details, I guess. Yes. So the total distance from here to here, that means this distance is 150-meter. Yes. Which is inclined at 0.8 degree to the horizontal. That means this angle right here is 0.8 degree. The speed of the athlete at the start of this section is 3 meter per second. That means when the athlete is right here, when the athlete is starting to run, his speed will be 3 meter per second. And what is the mass of the athlete? 84 kg. How do I know this? It was written down in the previous question. And now you'll tell me we'll have to mention this also. Power of 60 watt. No. Because this was sub question A. This is under sub question A. This is a general information we have given throughout the question, but this is not the general equation. Question the general information. This is the information they are going to solve A itself. And now when we are solving B, we need to completely ignore this because now our question does not have any reasoning to this. So don't think that power 60 you will consider. No. Here you will have to find out for new things. And he now produces a constant driving force of 24 Newton. Okay, new detail. That means because the athlete is running, he has to produce a force, and that force is 24 Newton. The total resistive force which acts on the athlete along a section of the road has a constant magnitude of 30 Newton. Now, resistance force will pull him backwards. So, and they have told us that that backward force is 13 Newton. So, I'll include that also. Now, the question is use an energy method to find the speed of the athlete at the end of the 150-meter section. So now you might think, oh my God, so many details are mentioned here. What should we do? What should we think about? What should we have first thought? So it is a very easy question to be honest. You'll understand why in a minute. Because they have given us a hint to use the energy method. And there is only one energy method in the entire physics, entire mechanics syllabus. That is work done by driving force is equal to delta Ke plus delta Gp plus work done against resistance force. That's it. That's what you need to know. And what do I mean by this? How do we do this? How do we solve? I'll explain you everything. No need to worry. And after this, when you try to solve a few questions like this, it will be very easy for you. So for that, but you need to understand this very clearly. So let's start. First is this work done by driving force. What is work done by driving force? Now, if you remember, right here we read that he produces a constant driving force of 24 Newton. So this is what this driving force is talking about. But this is work done. Do we know work done formula? Work done's formula is force into distance. So we know the force exerted by the driving force. So for work done by driving force, we'll need the force by driving force, constant force exerted by driving force into the distance covered while this force was exerted. So we know everything. The force is 24 Newton. Yeah, right here we have mentioned that. And distance is 150-meter. So work done by driving force will become 24 into 150. Quite easy. Perfect. Now next. Delta K. Delta K will be the speed of the velocity of the person here, the initial velocity, which I'll write u, is 3 meter per second. But do we know the final velocity of the person here? No. And that's what we need to find out. Find the speed of the athlete at the end of the 150-meter section. So that for that we'll require this Ke. So delta Ke, what does delta Ke mean? Delta Ke means the difference in the kinetic energy of the final and initial athlete. Athlete's final kinetic energy minus initial kinetic energy. So this will be kinetic energy is formula. I hope you all know half mv square. So this will be half into what is the mass 84 into the final kinetic energy we don't know minus half into 84 into 3 square. This is the delta Ke. This is the final Ke part, final, and this is the initial Ke part. I hope you guys understand this. and delta plus delta GP. Now, if I want to simplify this and write this into smaller terms, now this half 84, I can simplify. This will become 42. This will become 42. So this technically means 42 v square minus 42 into 3 square. So I can simply 42, I can put it in the bracket and write v square minus 3 square. So let me do that down. And why do we need this? Because it saves our space and it has the same marking, and marking scheme does not want the entire thing. It only, even if we show the simplified version, they are fine with it. So examiners will give us more mark, give us the same marks, and it won't matter. So I'll just write 42 v square minus 3 square, and let me erase this too. And now what about delta GP? Delta GP will be the change in height. The formula for GP is m into g into h, and actually mg delta h. So now this gravity always acts downwards. The mass is 84 kg, so its weight will be mg, which is 84 into 10, which is 840 Newton. So the weight is 840 Newton. Now let me use a different pen now. Hmm. Yes, blue. So this is 840 Newton. Now this height is 150 meter, but what is the vertical height that it will travel? Because h is not the total distance covered. This is h. What is the height? So we'll simply use trigonometry. Sine 0.8 is equal to 150 upon h. Nay, my bad. I reversed it actually. H is the opposite side, 150 the hypotenuse side. So sine 0.8 equals h upon 150. Therefore, h is 150 into sine 0.8. So if you put this in, no need to put this in the calculator. We'll simply write 84 into 10 into 150 sine 0.8. Yes. Plus work done against resistive force. Now, we do we we'll have to use the same concept as this. So we have found out work done against drying force. Now for work done against resistive force, we'll need force, a constant force exerted throughout the 150-meter distance on resistive force into distance traveled. So do we know this? Yes, we have mentioned it right here. The resistive force was 13 Newton. Even in the question, if we read it again, the road has a constant magnitude of 13 Newton. What constant magnitude? Total resistive force which acts on the athlete along this road has a constant magnitude of 30 Newton. That means the total resistive force is 30 Newton. Now, work done by resistive force will be 13, which is force into distance. Sorry, this one. Yeah, into distance. So distance will be 150. So we can write 13, not here, I'll write it down. 13 into 150. Yes. Okay, so now what we are going to do is we are going to we are going to use our calculator to simplify everything. So 24 into 150 will be, yeah, 24 into 150 will be 3600 is equal to 42. If we open this, 42 b square minus 42 into 3 square, which is 9. So 42 into 9 will be 378 minus 378. Wait, I'll have to use a different pen to differentiate this because this is not we are talking about right now. Plus 84 into 10 into 150 sine 0.8 will be 84 into 10 into 150 into sine 0.8. Yes, the answer is 1759.23 plus 1759.23 plus 13 into 150 will be 13 into 150, 1950. So now what we are going to do is we have to make b square the subject. So simply 42 b square is 3600 Putting it here will be plus 378 minus 1759.23 minus 1950. Then this entire thing b square will come down. Oh, sorry, 42 will come down, not b square. This 42 which I cancelled right now, I just put it down, and v will be the root of this entire thing. So now we'll put this in the calculator. Root of bracket 3600 plus 378 minus 1759.23 minus 1950 upon 42. So the answer is 2.53. That means the velocity is 2.5, yeah, 2.53 meter per second. That means the speed of the athlete at the end of the 1.50 meter. That means the speed here will be 2.53 meter per second. Initially, the speed was 3. Eventually, it reduced down due to the resistive force, and then it became 2.53 meter per second. And that's how we end this question. Let's start with the fifth question. A particle of mass 0.6 kg is placed on a rough plane. Now, by the word rough, we can understand that this question is particularly about friction, which is inclined at an angle of 35 degree. This is given in the diagram to the horizontal. The particle is kept in equilibrium. Now, this is a very important statement. Now, as they have told the particle is in equilibrium, that means the resultant force acting on the object is zero. By horizontal force of magnitude P Newton acting in a vertical plane containing a line of greater slope. This means this force is acting parallel to the horizontal. The coefficient of friction between the plane and particle is 0.4 Newton. Now, this is an important point. The coefficient of friction that we are given is 0.4 Newton. And we need to remember the formula for coefficient of friction is F by R. Yeah. So now that we have read the question, the final statement is find the least possible value of P. So in this case, there are two possible options for P. We'll solve for both and figure out which is the which is the answer with the lesser quantity, and we'll have that answer in the end. So what do I mean by that? So the first case is the P can act upwards. And the second case is that P will act downwards. So what do I mean by this? Let me draw a line here. This is P Newton. And one force will act upwards. That means this slope, let me write that as S Newton because this is the force that will act as a slope. So this is S Newton, and the other force will act downwards. This is the, let me label it as K Newton. Now let's talk about the P Newton acting downwards. So let me again draw P as, this is the P Newton. And with the green, no, with the orange pen, I will draw S Newton. But in this case, the S Newton will act down and the K Newton will act up. And this is 90 degree. Then this is 90 degree. So in the first case, when S Newton acts up, this will be the diagram. S Newton will act up and K Newton will act down. But in the second case, when S Newton acts down, we have to draw something like S Newton acts down and K Newton acts up. So let's now draw two different diagrams for these cases. P Newton act up, P Newton acting down. So here I have an inclined plane. The angle is 35 degree. This is the object. The object's mass is 0.6 kg. So the force exerted by the object will be 0.6 into g, which is 0.6 into 10. So the weight of the object is 6 Newton. So the downward force acting is 6 Newton. And the force acting on the slope due to the weight is mg sine theta. So technically 0.6 into 10 into g sine 35. So this is 0.6 g sine 35. And the contact force due to the weight will be 0.6 g cos 35. Let me similarly draw it right here. So this will be 6 Newton. This is 35 degree. This is 0.6 g sine 35. And this is 0.6 g cos 35. And now the main part being when the slope force is acting upwards, that is this S Newton, and the K will act downwards, K Newton. And when the slope acts downwards, when the force due to P acts down, this becomes S Newton, and the support force will become K Newton. So now that we have our diagrams ready, we'll go to the final step and we'll discuss where can the frictional forces act. So now let's start with the P acting downward case. So now as you can see, both the forces are acting down the slope. And what do we want? We want the ball to not move at all. Why? Because the system is in equilibrium, as they mentioned here. The particle is in equilibrium. And as it is in equilibrium, we do not want the ball to move at all. And so the frictional force must oppose the forces that are making the ball move. So both the forces are making the ball move down. So it is obvious that the frictional force will act upwards. So this is Fr. And now let's go to the P acting down upwards case. Here the forces are acting both down and up. Up the slope S Newton and down the slope 0.6 G sine 35. So there can be two cases. The either frictional force can stop the ball from moving downwards, or either the frictional force will stop the this frictional force will stop the ball from moving upwards, and this frictional force will stop the ball from moving downwards. So here we will have two equations and here one. So in short, we will have three equations. We'll have to find the value for P for all of them and then finalize which one has the lowest value for P. So how do we do that? Let's get right to it. So let me use this purple pen to form equation number 1. That will be 0.6 G sine 35. Now assuming Fr acts down. So I'll write plus Fr is equal to SN, S Newton. The second equation will be assuming Fr is up. So 0.6 G sine 35 is equal to S plus Fr. And the third equation, this is a relatively easy one, 0.6 G sine 35 plus S Newton is equal to Fr. So now we'll have to find the values for S and Fr. What do we mean by this S? What do we mean by S, Fr? So now to find S, we'll have to make P the subject because S is somehow related to P. And how is it related to P? Now let's understand that. So let me erase everything right here. This. Okay. So now, as we can see, this angle is 35 degree. And now also we can mention that this some force will act like this. This is K Newton, but we have already previously discussed, and this will be S Newton. So now, as you can see, that this angle will be 90 degree because it is perpendicular to, it is the hypotenuse of P. And these are alternate angles. Which one? This angle is an alternate angle. So this angle will be 35 degree. Why? Because as you can see, this if this angle is alpha, then this is alpha due to alternate angle theorem. So right now here I can write this P. If I redraw the diagram in a better way, this will be S, this will be K, and this will be 90 degree, and this will be 35 degree. So the angle between P and S is 35. So the angle between P and S is 35 degree. So here, let me redraw the diagram. 35 degree, 90 degree. This will be P Newton. This will be S Newton. Oh no, my bad. The hypotenuse side will be P Newton. This will be S Newton. And this will be K. So I can write cos 35 equals P is equal to S by P. Therefore, P is equal to, therefore S is equal to P cos 35. Why cos 35 is S by 3? Because cos is adjacent upon hypotenuse and adjacent side is S. Therefore, S equals P cos 35. So 0, if I input this in this equation, so 0.6 G. Now let me not rewrite the equations. I'll just write it here instead of S. So this S is P cos 35. Even this S is P cos 35. Even this S will be P cos 35. So now that we are done with S, we'll talk about FR. What is this force of friction? So we know that the formula for coefficient of friction is F by R, and we already know the coefficient of friction is 0.4. So 0.4 equals F upon R. What is this R? The R is the resultant contact force. So this force is R, and even this force is R. So even R will have two equations. The first equation for R will be R is equal to 0.6 g cos 35 plus K. And the second equation for R will be R plus K equals 0.6 g cos 35. So now what is this K? We can easily find K using this equation. So sine 35 is equal to K upon P. Therefore, K equals P sine 35. So instead of K, I can write P sine 35. Instead of this K here, I'll write P sine 35 again. So R can have two values. In this case, when P is acting downwards, when P is acting upwards, uh, R will be 0.6 g cos 35 plus P sine 35. And in this case, when P is acting downwards, that means when slope force is acting down, R will be 0.6 g cos 35 minus P sine 35. So now, so now that we have discussed the force, the R will go to what is F. So F is simply FR, force due to friction. So this FR right here, we don't know. We have to find. That's why we found R. So therefore, FR is 0.4 R, right? FR is 0.4 R. And R also, there are two equations. So the first equation we'll use in this case is first equation for R, and the second equation for R we'll use in this case. Why? Because the first equation of R we found it from acting up, which we can use in first and second. And the second equation we found from acting down. So the let me write down the two equations for R in a proper manner again. So the first equation for R is 0.6 g so cos 35. So for here, FR will be 0.4 into 0.6 g cos 35 plus P sin 35. And in this case, FR will be 0.4 into 0.6 g cos 35 minus P sin 35. So this is 0.6 g cos 35 minus P sin 35. Now finally we have everything. So here instead of FR we can input this. Instead of FR we can input this. And here in case of this FR we can have this. So let me substitute it here. 0.60 sine. Let me find out the value for 0.60 sine 35. 0.6 into 10 into sine 35. So the answer is 3.4415. So 3.4415. Let me wait a minute. 3.4415 plus FR. What will FR be? FR will be 0.4 bracket 0.6 into 10, 0.6 into 10 into cos 35. So this is 1.966 plus 1.966 plus 0.4 p sine 35. So this will be 0.4 sine 35. So the answer for this 0.229 plus 0.229 p. And now that we know FR, the last will be equals P cos 35. So this is our first equation. Now going to the second equation. 0.6 g is sine 35, we know 3.4415 is equal to P cos 35 plus FR. FR we also know 0.4. This is FR 1.996. Sorry, 1.966 plus 0.229 P. And we'll go to the third equation now. 0.6g sine 35, we all know 3.4415 plus P cos 35. Now this will have a different value for FR. So we'll have to calculate it again. But 0.4g cos 35, 0.4g cos 35 is the same. So 1.966 minus P sine 35 into 0.4. And this was P sine 35 into 0.4. So it's just a matter of the negative sign. This is 0.229 P. So now we can use the calculator to input all the values, which is, 1 second. So we can, instead of P, we can write X in the calculator and directly find the answer. What do I mean by that? I'll show you 3.4415 plus 1.966 plus 0.229, and instead of P, I will write X is equal to alpha and equal to P cos 35. So instead of P, I have to write X. So that is X cos 35. And now what I have to click is shift solve, and solve for X I have to press equal to. So I got the value for P. So the value for P in the first case is 9.163. So value for P in the first case is 9.163. 1 second, what is happening? So P is 9.163 Newton. And going to the second case now, 3.145. Now the only thing here is the P cos 35 is shifted to the right. So P cos 35, sorry, the 1.966 plus 0.229 has shifted to the right. So what I can do is remove this equal to sign. I can add a plus, and I can add an equal to here. So 3.4415 is equal to 1.966 plus 0.229 p plus p x cos 35. Let me check it again. Plus 0.229 p plus x. Yeah. Then again shift solve for x. The answer for x is one. The answer for p is 1.408. So here the answer for p is 1.408. And here in the third question, third equation, I'll write again 3.145. Then p is shifting here. Okay. X cos 35, I have to move it there. X cos 35 plus 3.1445 is equal to 1.966, and this will be minus 0.229 p. Then again shift solve for x. The answer I got is minus 1.017, minus 1.408. So the answer cannot be negative p, because this is a force, and the force we found out cannot be negative. So the least possible value is either in between 9.163 and 1.408. So the final answer we get is 1.408. Now we'll break down these answers. Don't worry. So what does this first case, what did this first case mean? So this first case meant that FR is acting downwards. Why? Because the 0.6 G sin 35 and plus FR, they are written on the same side. So that means they are both down and S is up. So the value for P in this case was something 9 point something something. The second case was that FR will act downward, FR will act upwards, and it will act according with S, and the ball was on the verge of moving downwards. So for that case, the P was just 1.407. So that means this is the least value of P, and here the answer was in negative, so this is not required at all. So our final answer is 1.407 Newton. This. And this took a lot of space because I had to show diagrams and do a lot of working. But when you will write the answer, you don't need to do so much and you will get the answer easily. Just the important thing here is you have to identify all the cases. For example, if forces are acting on both sides. So friction can too act on both sides. Because it could act on both sides, that's why we got two answers, right? When first answer was p point 9 point something, the second answer was p equals 1.4 something. So here you have to identify this all these cases, for solve for everything, and in the end find the final answer. So the final answer here is p equals 1.408, and that's how we end this lengthy question. Let's move to the sixth question. A particle p starts at rest. Now, by starts at rest, the first thing we need to understand is that the initial velocity will be zero. So I can mention it here only the width, not micro. I simply have to write a u. Okay. So initial velocity is 0 meter per second. Moves in a straight line from point O. After time t leaving 0, the velocity of particle B is given by this. So this is the equation where B and C are constants. P has a velocity of 8 meter per second when t is 4 and velocity 13.5 t is 9. So if I write something such as a velocity time coordinate here. So when velocity is 8, time is 4, and when velocity is 13.5, time is 9. And we have an equation here, v equals bt plus ct h to 3 by 2. So I can input the value for v and t here. So when velocity is 8, time is 4. So this will be b into 4 plus c into 4 raised to 3 by 2. And next, when velocity is 13.5, the time is 9. So b bracket 9 plus c bracket 9 3 by 2. So now let me put these in the calculator here. So first I can write 4b plus what will 4 raised to 3 by 2 be? So 4 raised to 3 by 2 is root of 4, 8. That is 8c. You can put this in the calculator and check. So the 4b plus 8c is equal to 8. And 9b plus 9 raised to 3 by 2 will be 27c is equal to 13.5. Now I will put these values in the calculator because this is a simultaneous equation right here. And I can find the value for B and C and what they have told us to show the value for B and C. So putting this in the calculator, how will I do this? First we'll have to select mode, then fifth equation, and then 1 because this is ax plus by plus c. So this gives us the simultaneous equation. So 4, 8, 8, 9, 27, 13.5. So answer B is 3 and C is minus 0.5. Therefore, we can write here B is 3 and C is minus 0.5. Next question. Find the acceleration of P when T equals 1. So right here, we have the equation for a velocity time graph. This is the equation for a velocity time graph. Why? Because here they have mentioned velocity and time. So from velocity to time, if we need acceleration time graph, then we'll have to derivate the equation. So let's start derivating this equation of v equals bt plus ct raised to 3 by 2. So if we derivate dv by dt, which is derivation of bt plus ct raised to 3 by 2 upon dt. So this becomes b plus 3 upon 2 ct raised to 3 upon 2 minus 1. Therefore, dv upon dt is equal to b plus 3 by 2 c t raised to 1 by 2. Now we already know the value for b and c. The value for b and c is 3 and minus 0.5. So here I can, instead of b, I'll write 3. And instead of c, I'll write minus 0.5. Now I can further simplify this to 3 plus, not plus, minus. Because minus 0.5 we multiply, the whole answer will be negative. So minus 3 upon 4 t raised to 1 by 2. Now what they have told us to find the acceleration of when t is 1. So dv by dt is technically a. So a is 3 minus 3 by 4 t raised to 1 by 2. Now we can put t as 1. Therefore a will be 3 minus 3 raised to 1 raised to 1 by 2 upon 4. Therefore a is 3 minus 3 by 4. So the answer, final answer is 3 4s are 12. 12 minus 3 is 9 by 4, which is 2.25 meter per second square. So the acceleration at time t equals 1 will be 2.25 meter per second square. Now, next, going to the next question. Find the positive value of t when p is at instantaneous rest. Positive value of t when p is at instantaneous rest. That means time at which velocity is 0. And that is not the end of the question here. The second part is find the distance of p from O at this instant. So let us first understand the first part of the question. Positive value of t when p is at instantaneous rest. So we already know the equation. V equals 3t minus 0.5 t raised to 3 by 2. So we have to find the time at which v equals 0. So equating it to v equals 0, we'll get 3t minus 0.5 t raised to 3 by 2. Now what we can do is 0 equals, we can have t in the t as common. So we'll get t minus 0.5 t raised to 1 by 2. Now how did I get t raised to 1 by 2? T multiplied by what value of t will give me t raised to 3 by 2. So I can do that by tx will be t raised to 3 by 2 upon t. And by that I'll get 3 raised to 2 minus 1, which is t raised to 1 by 2. Therefore, tx is equal to t raised to 1 by 2 and x is 1 by 2. So hence I got t raised to 1 by 2. I hope this is grade 9 maths and I don't need to explain this any further, I guess. Let me erase this. Yeah, now moving further, I'll get two answers. T equals 0 and 3 minus 0.5 t raised to 1 by 2 equals 0. Therefore, 3 equals 0.5 t raised to 1 by 2. And putting 0.5 down there equals t raised to 1 by 2. And this t raised to 1 by 2 is, which is root of t. 1 second, I'll have to, t raised to 1 by 2, which is root of t on that side, it will go and it will become squared. Therefore, t equals 6 squared, which is 36 seconds. So that means at when time equals 36, the velocity is 0. Let me erase all of this again. So that means the answer is time equals 36 seconds. Now the next question they have asked us is find the distance of t from O at this instant. That means if I draw a graph here, the velocity at t equals 0 was 0. Why? Because here we found out when t equals 0, velocity is 0 and velocity is 0 at 36. So the graph looks something like this. So what they have told us is to find the distance covered. So in order to find the velocity from the velocity time graph, we need to find the displacement time graph. What we need to do is we need to integrate the equation. So now we are going to integrate the equation. V equals v integral of v dt, which is integral of 3t minus 0.5 t raised to 3 by 2 dt. So the integral of dt is s, so s, and we'll have to put the limits of 36(0) here, 36(0). So this will be 3t square upon 2 minus 0.5 t raised to 3 upon 2 plus 1 upon 3 upon 2 plus 1. And the limits are 32 comma 0. Now the final step will be a little simplification of this. So 3t square by 2 remains the same minus 0.5 t raised to 3 upon 2 plus 1 will give me 2, 3 plus 2, 5, which is 5 by 2. You can do this in the calculator also upon 5 by 2. Now this 2 will go up and become multiply, and this 5 will simply cut. So 0.5 upon 5 is 0.1 upon 1. And this will 2 will go up and it will become multiplied by 2. So, and the limits are 36, 0. So finally what we got is 3t square upon 2 minus 0.2 t raised to 5 by 2. And the limits are 36 and 0. And now let me put the limits in the calculator. So instead of t, I will use x. So it will be 3x squared upon 2 minus 0.2 x raised to 5 by 2. And here, many of you students won't know there is an easy method. You can click calculate and you can put x as 36 here. And you'll get the answer 388.8. So S is equal to 388.8 minus, now we will put x as 0, again press calculate and put x as 0 and the answer is 0. So anything minus 0 is the same, so we can simply erase this and our final answer is 388.8 meter, and that means that between 36 and 0 the distance covered by the car or the vehicle is 388. What is here? A particle. Okay. The distance covered by the particle is 388.8 meter. We moving to the next question. Find the speed of the P at the instant it returns to O. So in order to find the speed of P at the instant it returns to O, and what does this question mean? Let me read the diagram. Yeah. So initially we had something like this, right? Where v t, this was 36 and the object was going like this. Now that means the object will continue like this, the particle, and that means because the velocity is negative here. Initially, if the particle was moving like this, when velocity turns negative, the particle starts traveling like this. So that means once the particle, let us assume the particle started from here, point O. Then it went ahead. After some point, it started coming back. So there will be some point where it returns to the original position O. So they have told us to find the speed of P at that instant. So for that, first we'll need to find out the time taken for the particle to reach that instant. And from the time, we can find the velocity. Now, how do we do that? So we can use the limits again. We know that S is equal to 3t square upon 2 minus 0.2 t raised to 5 upon 2. Now, what we know is in order to the particle initially this distance was 388.8 meter. So in order to return to 8 O again, it will have to travel 388.8 meter again. So what we know is the displacement of the particle or the distance that should be traveled by the particle is 388.8. And the other thing we know is we don't know at what time. Let this be X. We don't know what time does it reach. But we know that this is 36. That means the area under the graph should be somewhere here. So now let us solve this. So 388.8 is equal to 3x square upon 2 minus 0.2 x raised to 5 by 2 minus, now if you put 36 here, we have already put 36 and we know what the answer is. The answer is 388.8 meter. Okay, so what you need to know is this should be the distance traveled, the displacement. Initially, we considered positive here in this case. One second. Initially, the distance was positive here. So when the particle is traveling in the opposite direction, the displacement will be negative. So the particle does not need to travel 388.8 meters. It needs to travel minus 388.8 meters. So here it will be negative. And then what we need to do is finally we need to simplify the equation. So 388.8 goes there. So 388.8 minus 388.8 is equal to, and x we can take in the bracket. So this will be 3x upon 2 minus 0.2 x raised to 3 by 2. So this cancels out. So 0 equals x bracket 3x upon 2 minus 0.2 x raised to 3 by 2. So x is 0 and 3x upon 2 minus 0.2 x raised to 3 by 2 is 0. So again, we can take x in the bracket here. So x bracket 3x upon, 3 upon 2 minus 0.2 x raised to 1 by 5, 1 by 2 equal to 0. So x will equal 0, or 3 upon 2 minus 0.2 x raised to 1 by 2 is 0. Therefore, here finally what we can do is 3 upon 2 is 0.2 x raised to 1 by 2. This 0.2 will go down, 0.2 into this, and this 1 by 2 will become squared. So let me use my calculator right here. So 3 upon 0. Yeah, 3 upon 0.2 into 2 raised to 2 the whole square. So the answer here is 56.25. That means x equals 56.25. And now what was x? X x was the time it takes for the particle to reach O again. So here that means somewhere at 56.25, the particle will travel distance. That means this distance was the area under the velocity of diagram is distance. So this is 388.8 meter. And that took 36 seconds. And again, between 36 and 56.25, the area covered under the graph will be 388.8 meter. So the time taken for this will be 56.25 seconds. And that's how we have our final answer. So the question was find the speed of, no, this is not the final answer. For the speed of the P at the instant it returns to O. So we know, let me write down right here. We know the equation V equals 3t minus 0.5 t raised to 3 by 2. Well, let me check this. Minus 0.5 t raised to 3 by 2. Yes. And we know that the time we have to input is 56.25 seconds. So the velocity at this will be 3 bracket 56.25 minus 0.5, 56.25 raised to 3 by 2. So now if I put this in the calculator, 3 bracket 56.25 minus 0.5 bracket 56.25 raised to 3 by 2. So the answer we got right here is minus 42.19. So the velocity is minus 42.19 meter per second. But what they have asked us for is the speed of P. And speed does not have any negative signs. So our final answer will be 42.19 meter per second. And that's how we end this question. Let's start with the seventh question. Two particles P and Q, mass 2 kg, 0.5 kg. 1 second. Yeah. Mass is 2 kg, 0.25 kg. Connected by light and inextricable string, passes over fixed pulley. Angle of 30 degree. Q hangs below pulley. Okay. 3 points ABC, line of greatest slope AB 0.8, BC is 1.2. Particle P is released from rest start A. Now this is important. That means the initial velocity of particle P is 0. And the string and from rest at A with the string taut. Now what does taut mean? So taut means is, for example, if I have a pendulum here on a wall and this is connected by a string, and if I say that this string is taut, that means the string will not bend. Why? If we put a spring here and if we put a pendulum, then the spring will bend, right? The spring will bend a little and then it will go down. But if there is a string which is taut, the string will not bend. That's what they mean to say. During the motion from P to C, Q does not reach the pulley. Okay, so that means until P reaches C, when P will reach C, Q will not reach here. Q will be somewhere here or here, but Q will not touch the pulley. The part of the plane from A to B is rough. That means AB will have friction, and in which the coefficient of friction is 0.3. That means the coefficient of friction between AB is 0.3. And the part of the plane BC is smooth. That means there will be no friction here. No friction. Yeah, so now that we are clear with all the details, let's go to the final question. Find the acceleration of P between A and B. So we'll have to find, in order to find the acceleration of P, what we have to do is, we have to use the formula for, we used to have the formula which is F resultant is equal to mass into acceleration. So what will be the F resultant of the system? So as you can see, this mass is 2 kg. So the downward force will be 20 Newton. And so the force parallel to the slope or across the slope will be mg sine theta, which is 2 into 10 into sine 30, which we put in, if we put in the calculator, will be 10 Newton. So this is 10 Newton. Then there will be some frictional force during AB, and what they have asked us is to find the acceleration of P between AB. So the frictional force, let it be Fr, frictional force, and this downward force due to weight will be 0.25, W will be 0.25 G, which is 2.5 Newton. So this is 2.5 Newton. Now there will be another force which is tension on the spring. One will be here and the other will be here. This will be the tension force. But because the tension forces are opposite each other, one tension is like this, the other is like this, the resultant tension is zero. The resultant tension will be zero. So we do not consider zero here. So what are the resultant forces here? Let us, because we know that acceleration will be downwards, so the downward force we'll have to consider positive. So there is only one force acting downwards, that is 10 Newton. So 10 Newton minus the frictional force minus the 2.5 Newton force is equal to, now what about the mass? So the mass you'll have to consider both the 2 and the 0.25. Why? Because we have considered this also 25, because because we can't only calculate the P for acceleration for P, because even Q is affecting the moment of P, right? So you'll have to consider the whole system. So that we have to take the total mass, which is 2 plus 0.25 into acceleration. Now, how can we find Fr? In order to find Fr, we need to know the formula UR. That is correct. And we know U is 0.3. And what about R? So here R will be mg cos theta, which is 20, wait a second, which will be 2 into g, which is 10 into cos 30. So this is 20 cos 30. 20 cos 30. So the answer for this, let me put it down in the calculator, 0.3 into 20 cos 30. So the answer is 3 root 3. So the force due to resistance or frictional force will be 3 root 3. Therefore, 10 minus 2.5 is 7.5. So I'll simply write 7.5 minus 3 root 3 upon 2, 2.05, 2.25. How did this 2.25 come from? This went down, is equal to A. So the acceleration is equal to, let me put this in the calculator now, 7.5 minus, 7.5 minus 3 root 3 upon 2.25. So the answer is 1.024. So the answer is 1.02 meter per second square. Now, let's move to the next question. Hence, find the speed of P at C. That means we know the acceleration, we know the speed at A. Now what they are telling us is to find the speed of C. That means when P reaches here, when P comes here, what will be the velocity? That's what they are asking us. And how will we find that now? Even this is a very easy question. In order to find this, what we need to do is, first you have to find the velocity. We need to find two things. What are the two things? Let me write that two things down here. First, velocity of P at B. And the second thing is acceleration of P on BC. So velocity of P at B we can find very easily because we know the acceleration at AB, which is 1.02 meter per second square, which we just found out. We know the distance of AB, which is 1.2 meter. Let me check if that is correct. No, that is 0.8 meter. My bad. So this is 0.8 meter. And we will know the initial velocity at A, which is 0 meter per second. So right now I can use the formula. Yes, we can use this. V square equals U square plus 2AS. We can find out V because we know U, S and A. So let's do it quickly without wasting any time because this is relatively easy. P equals root of U square will become 0 square. So 0 square is 0, 2 into 1.02 into 0.8. So the answer is 2 into 1.02 into 0.8. 1.632. So root of 1.632 is 1.28 meter per second. 1.28 meter per second. And now that we know the velocity of P at B, that means the velocity, let me erase everything. 1 second. Yeah, let me erase everything right here. That means the velocity of P at B was something 1.2 meter per second velocity. And now what about BC? So first we'll have to find the acceleration that will occur at BC. So acceleration will be this same thing. only one thing will not be there. And what is it? That will be that there will be no frictional force. Why? Because they have told us that the part of BC is smooth. So simply 10 minus 2.5 is equal to 2 plus 0.25 into A. Therefore, 7.5 upon 2.25 equals A. So 7.5 upon 2.25 will be 7.5 upon 2.25. The answer is 10 by 3. Therefore, acceleration is 10 by 3 meter per second square. Now, what we can do is we know the acceleration, we know the initial velocity, we know the distance. So we can again use v square equals u square plus 2as to find out the velocity at v. So u square will be 1.28 square plus 2. Acceleration is 10 upon 3. S is 1.2. So if you put this in the calculator, root of 1.28 square plus 2 into 10 upon 3 into 1.2. So the answer we get is 3.1. That means the velocity at C will be 3.1 meter per second. Oh, sorry, not second square, meter per second. That means when the ball reaches here, when the ball reaches here, the velocity will be 3.1 meter per second. It's 3.1, right? Yeah, 3.1. Now moving to the next question. The next question is find the time taken for P to travel from A to C. Find the time taken from P for P to travel from A to C. This is a very, very easy question. Why? Because we can simply use V equals U plus AT both the times. For example, let me make it very easy for you. This is A, this is B, this is C. The velocity here was 0. The velocity here was, the velocity should be denoted by a V. So the velocity, one second. Yeah, the velocity at B was, where did it go? Yeah, velocity of P at B was 1.28 meter per second. 1.28 meter per second. And the velocity at C was 3.1 meter per second. And we know U for everything. We know acceleration between AB was acceleration between AB 1.02 meter per second square. And our acceleration between BC was acceleration of P at BC was 10 by 3. 10 by 3 meter per second square. So now we can use this. So for covering AB, that is time for AB will be V will be 1.28, U will be 0, A will be 1.02 and T. So therefore 1.28 upon 1.02 is T. Therefore time taken for the particle to travel between AB will be 1.28 upon 1.02, which is 1.28 divided by 1.02. That is 1.255. 1.255 seconds. And the time taken for BC will be, the final velocity is 3.1. The initial velocity is 1.28. 1 second. 1.1. Initial velocity is 1.28 plus acceleration is 10 by 3 and we have to find out the time. So therefore the time will be 3.1 minus 1.28, answer upon 10 by 3. So if I put this in the calculator here, 3.1 minus 1.28, the answer divided by 10 upon 3. Yes, so the answer is 0.546. That means the time taken for traveling between BC is 0.546. Now, what have the question asked for? The question has asked for the time taken for P to travel from A to C. That means we know that for AB it has taken 1.255 seconds and for BC it has taken 0.546. So the last step remaining is we simply add up the two. So total, one second, let me use a different pen. Yes. The total time will be 1.255 plus 0.546 is equal to, let's use a calculator, 1.255 plus 0.546, and the answer is 1.8. So the total time required to cover this distance is 1.8 seconds. Total time is 1.8 seconds. And that's how we end our question 7.